Hello students, welcome to Akshara 8 Foundation. So yesterday we have started the new topic, that is rotational kinematics, rotational mechanics. In the rotational mechanics we have studied about the angular kinematics, okay. So some of the angular kinematics we have studied there, and the equations of angular kinematics also we have seen there. So now today we are going to see there some of the relations between this angular acceleration and tangential acceleration. Then we are going to see the linear velocity and angular velocity. Okay, so afterwards we will be moving into the numericals. We are going to do there. Okay, so first we'll see there relation between angular velocity, linear velocity and angular velocity. Linear velocity and angular velocity. Angular velocity. So angular velocity is denoted by omega and linear velocity is denoted by v there. Okay. So the relation between angular velocity and linear velocity. Okay. See now here, suppose if an object is moving in a rotatory motion or in a circular motion, so we have, suppose this is a radius if we consider, and this is a radius and the angle made by it is theta, this is a radius, and this one is the arc, there is an arc there here, so this is the arc. So now we have the relation is there, no? So relation between arc and the angle, okay. So now here arc is equals to radius into angle, we can write there, radius into angle. So arc is denoted by, suppose here s, and this is a, so here we can write r into theta. So now if I differentiate this above equation with respect to t, okay, so differentiate with respect to t, okay, of above equation. So we'll get here d by dt of s is equals to d by dt of here r into theta. So whenever a body is moving in a circular path, radius is a constant. So if it is a radius constant there, so we'll get here ds by dt is equals to, we can write here r, we can take common there. So because radius is a constant there, okay. So then d theta by dt will get there, d theta by dt. And we know that here velocity, linear velocity is nothing but rate of change of displacement. This is the rate of change of displacement. And this omega is nothing but here, omega is equals to rate of change of angular displacement. Now we can here we can replace this ds by dt with v and d theta by dt with omega. Okay, so we'll get here v is equals to r into omega, will get there. So now this is the relation between linear velocity and angular velocity. Linear velocity is denoted by here v and angular velocity is denoted by here omega. Okay, so this is a one relation there. And next one we are going to see here centripetal acceleration. Okay, so centripetal acceleration. So the acceleration with which an object is moving in a rotatory motion or in a circular motion, the acceleration acting on the particle along the radius toward the center is called the centripetal acceleration or the radial acceleration. So whenever an object is moving in a circular path, so along the radius on the particle which is moving in a circular path, so along the radius there is a acceleration will be acted towards your center there. So that acceleration is said to be the centripetal acceleration or radial acceleration. So it can be denoted by centripetal acceleration or a suffix c or a suffix r there, ar. Okay. So we know that the force is acting on the particle is mass into acceleration, we can add there. Okay, so whenever this is acting here, see now centripetal force will be back there. Centripetal force formula m into v square we can write there. M into v square by r will be the centripetal force. Centripetal force there. This is a centripetal force. Centripetal force. Centripetal force. So centripetal force is equals to formula is this one. So that is equal to, we can write here, mass of the body and acceleration. Here acceleration along this one. Acceleration along the center, towards the center. Okay, now here this mass and mass will be cancelled there. So therefore here AC is equals to, will get there, v square by r will get there. So this is a centripetal acceleration formula. That will be the centripetal acceleration formula. Okay. So now here there are, whenever the body is moving in a rotatory motion or in a circular motion, so when the rigid body is rotating about the axis, then all the particles of individual particles of the body, they are rotate in the circular path. Okay, at the same time now. So then if they are moving in the circular path, all the particles are moving in the circular path, then along this tangent, along the tangent there is a tangential acceleration also, it will be takes place there. Along the tangent, because of the velocity, here the particle is came here means the velocity will be like this, means that the direction of the velocity changes. If the direction of the velocity changes, then the acceleration of the body is also changes. So then here we will get there the acceleration along the tangent of a body whenever it is moving in a circular path. So that is said to be the tangential acceleration. Now we are going to see the expression for the tangential acceleration. Okay, here change in velocity, okay, change in velocity per time is said to be the tangential acceleration. So now we'll see the tangential acceleration. Tangential acceleration. Tangential acceleration. So it is denoted by AT. Okay. So I said already, no, it is the rate of change of tangential velocity. So now here we can write that AT is equals to dv by dt, we can write there, dv by dt. Okay. So then here we have got the relation, no, relation between linear velocity and angular velocity is v there. So here if you write there, tangential acceleration t is equals to d by dt of here r omega, we can write. Same, if a body is moving in the circular path, so then the perpendicular distance or the radius of the circle does not change, it will be constant there. So AT is equals to this, it can be taken out from the differentiation. So here we will get there d omega by dt. So d omega by dt is nothing but what there, angular acceleration. So since here alpha is equals to, we can write there d omega by dt. So if it is a d omega by dt, then if you replace there, we will get the tangential acceleration formula is r is equals to so AT is equals to tangential acceleration, AT is equals to alpha into r or r into alpha. This is the expression for the tangential acceleration. Now total acceleration on the body there. Okay. So if a body is moving like this, now if a body is moving here, so say over the center there is a centripetal acceleration will be act there. Along the tangent there is a AT will be act there. Now the velocity of the body, acceleration of the body, the resultant of these two, it is said to be the resultant acceleration, actual acceleration acting on the body there is. Okay, that can be written as here A is equals to, by using here magnitude, resultant magnitude, we will get here square root of AC square plus AT square will get there. So now AC, this one what we got there here, this one, so V square we got now. So in this equation, in the previous one, here already we know that V is equals to here R omega, no, R omega. If you substitute here in this equation, if you substitute, then this centripetal acceleration will become R square omega square divided by, so here R is there, no, this is a radius only. So radius means here R is equals to, we can write a small r, this is a small r. Okay. So now if you write here small r, this R and R will be cancelled there. So therefore here we will get centripetal acceleration formula is also, it is R into omega square, R into omega square. Now this formula will be right here in this equation. Okay, here we will write there. So here R into omega square whole square plus here R into alpha whole square will write there, R into alpha whole square. So therefore acceleration of the body can be written as here. So we can take R common. So here it will be remain as omega power 4 plus alpha square will be there. Okay, this is the acceleration acting on the body whenever the body is moving in a circular path. When the body is moving in the circular path, so this is the equation we will get there. A is equals to r into square root of omega square plus omega power 4 plus here alpha square. Okay, alpha square is what there? It is the angular acceleration. Here omega is nothing but angular velocity. Okay, so now we have completed all of the concepts. So now we are going to see here the numericals. See, in the concept based questions, in the practice sheet, there are concept based questions are there. Based on this, all the formulas, there are the questions are there. Then we can see them. Okay, you can solve all the concept based questions there. Simply based on the formulas, they are there. Then directly we are going to solve their exercise problems there. Or even in the concept based questions, there are 3 problems are there from 7th onwards. So we'll solve their 7th problem onwards there. Okay, conceptual bits you try to solve them. Okay, we'll see the 7th problem onwards. Okay, now we'll see numericals, concept based questions. The 7th problem you see there here. See here, this is the 7th problem. Okay, so see there here. Yes, an automobile engine starts from rest is given an angular acceleration 20 radian per second square. Angular acceleration is 20 radian per second square for 10 seconds. Find the angle turn during this period. Find the angle turn during this periods. Okay. So now here we'll see there 7th solution. See here, angular acceleration is denoted by what there? Alpha. Alpha is equals to 20 radian per second square. 20 radian per second square. Alpha is equals to 20 radian per second square. And time is given here. Time is equals to what they given here? Time 10 seconds is given there. Time 10 seconds. Okay. And it is started from the rest. It is started from rest means, so we can write here omega 1 is equal to 0. Omega 1 is equal to 0. Omega 1 is equals to 0. Then they are asking there theta, angle turn. Angle is nothing but what there? Angular position. Theta, no? What is the theta they are asking there? What is the theta? Okay. So now we have know that we studied the equations of angular kinematics. We have seen now. So from there, here theta is equal to take second equation of motion. Second equation of angular kinematics, that is theta is equals to omega 1 into t plus half into alpha into t square. This is the formula, no? So now substitute here, all the values are there here. So alpha is there, omega 1 is there, t is there, and theta we should find out there. Okay. So now here omega 1 is what there? It is a 0 and time is given here 10 seconds plus half into this is 20 radian per second square is given alpha, and time is here how much it is given there? Time 10. So 10 whole square. 10 whole square. So it will become here 1 and here 10. So then how much? This will become 0 now here. So therefore from this theta is equals to, from here theta is equals to 10 into 0, it will be 0 only. Then here we'll get remaining is what there? 10 into 10 square, 100 means it will be 1000 now. So we'll get there 1000. So 1000 radians will get there, 1000 radians. So therefore the answer is here theta is equals to 1000 radians. 1000 radians. So this is the answer. It's clear? See, next one is either here a belt passes a wheel of diameter 200 centimeters. 200 centimeters. If a point on the belt has angular speed of 20 radian per second. Okay. See here it is given. A belt passes a wheel of diameter 200 centimeters. If a point on the belt has angular speed 20 radian per second, the belt is moving with velocity of. The belt is moving with velocity of. So we should find out the velocity. So what is the velocity here? You see here in the options it is given there meter per second square. So meter per second. Meter per second means it is a angular, it is a linear velocity. Just now we have studied about the relation between the linear velocity and angular velocity. It is given now. Okay, here angular velocity is given already here, and the radius is given there. Can you find out now linear velocity? We have the relation between linear velocity and angular velocity. V is equals to r omega. It is given now. Yes. By using that we can find out. Is it over now? So we'll see now here. We'll see the next eighth one. So here angular velocity is given. Angular velocity, how much it is given there? Angular velocity, eighth solution is now. Angular velocity is given there. So omega is equals to 20 radian per second is given. 20 radian per second. 20 radian per second. Okay. And here r is given there. R is equals to 200 centimeters. 200 centimeters, how many meters? We should convert that into meters there. So this we can convert. If we convert into meters, it will become 2 meter per second or 2 meter per second. Since 1 meter is equals to 100 centimeters. Okay, from this we can add there. That is a 2 meter per second. And they are asking V here. What is the V? So V is equals to R omega. V is equals to R omega here. This is the formula there. Now substitute here in this formula. V is equals to R value. How much it is there? R value. Sorry. So here it is this one now. So this is only meters, not meter per second, no, centimeter. So here we will get there. This is meters. Okay. So now it is 2 meters. 2 into this will be how much there? 20, no? Simply it is. So therefore V is equal to how much you get there now? 40. 40 meter per second. 40 meter per second. That is the answer. 40 meter per second. So what is the answer here now? This one will become there. Third one. It's clear, no? In the first one, what we got their answer? That also third one only we got their answer. Okay. Is it clear? Yes. Now we'll see the next one. So here ninth problem is there. Ninth problem. So see the ninth one, what they have given here. Ninth problem is there. So ninth one you see here, the length of the seconds of hand of the watch is 10 mm. What is the change in the angular speed of the watch after 15 seconds? Okay. So ninth one you see here, ninth problem. So ninth solution we'll see. The length of the seconds hand. See in the watch, so seconds hand like with this, no? This is a 12 and this is a 6. Here it is 3 and this is a 9 there. So length of the seconds hand. So length of the second hand. This is considered there. It is given this length of the seconds hand. It is given there 10 mm. 10 mm. So means we can consider that is the radius. Means R is equals to we can write here 10 mm. So 10 mm, no. So 10 mm. So 10 mm will be converts into meters. So how can we convert 10 into 10 to the power of minus 3 meters now? Okay. So 1 meter how many millimeters? 1000 millimeters, no? 1 meter. Okay, 1 meter is equal to 1000 millimeters. Then 1 millimeter is equal to 1 by 1000. Means that is 10 to the power of minus 3 meters will get there. We converted that into meters there. And what is they given there? Time is given there. Time. So T is equals to how much they given? T is equals to 15 seconds. T is equals to 15 seconds. Okay. T is equal to 15 seconds is given there. So what is change in angular speed of the watch after 15 seconds? Okay. So change in speed they are asking there. So 15 seconds means it will be like this, no? It will become from here to here there. Means 12 to 3. Means that is a quarter part, it will be rotate, quarter part. Then what will get here this They are asking the speed, no? Change in angular speed there. Change in angular speed means we should find out the linear speed there. Linear speed, how to find out, no? So V is equals to, we can write there. First we should find out linear speed, no? So then that is quarter part means this arc we should find out. What is this arc there? So arc, it is total circumference, no? Circumference of this circle is how much there? We can write there 2 pi r. 2 pi r by quarter part, no? So we can write here. So 2 pi r by 4. 2 pi r by 4. 2 pi r by 4. So we write here first this one. 2 pi smaller radius, no? Here we have to take radius there. This is seconds. So 2 pi r. 2 pi r will write here. 2 pi r by 4 divided by time, no? Time is how much it is given there? T. T, how much it is? 15 seconds is given there. Okay. So now how much we get it there here? So that is 2 pi into r value, how much it is given there? 10 into 10 to the power of minus 3. 10 into 10 to the power of minus 3 divided by 4 into here t, how much it is? 15. 15 seconds. 15 seconds will get there. Okay. So now it is 2 ones and here 2 twos will get there. This is a 5 and here it is 3 will get. Okay. So here we'll get there V value we got here. V value how much we got there? So pi by 3. So pi by 3 into 10 to the power of minus 3 will be there. 10 to the power of minus 3. So that is a meter per second. This is a meter per second there. So now angular velocity. This angular velocity they ask, change in angular velocity. Change in angular speed. Okay, change in angular speed means, so we can write here omega is equals to how much, how can I write there? So V into R, no? So here V is equals to R omega, no? Here we can write there. The relation here from this V is equals to R omega we can write there. So from this omega if you want to find out, omega is equals to, so V divided by R we can write, V divided by R. V how much we got there, this one, no? Okay, divided by R we should write there, divided by R. So what is the R here? Omega is equals to, so V value pi by 3 into here into 10 to the power of minus 3 will get, and R value it is given there 10 into 10 to the power of minus 3. 10 into 10 to the power of minus 3. So this is, here it will be cancelled now. This is into here. So this term and this term will be cancelled now here. So pi by 30 will be there. Pi by 30 meter per second. Okay. So angular speed, change in angular speed they ask there. Change in angular speed means, so from 12 to here, 15 seconds means it will be like this, no? Here, from here to here it will come, that means 12 to 3. 12 to 3 will come there. Okay. So we'll get here this omega is equals to 5 by 3 into 10. So therefore here omega value will get here, omega value it is, how much we get there here, that is pi by 3 pi by 10 we can add. Pi by 10 means here pi by 30 we can add there. Pi by 30. Pi by 30. Okay. So next 10th one we will see there. 10th one. A car is going around a circle of radius R1. This is a R1 it is, not 1 into R, R1 with the constant speed. Another is going around a circle of radius R2. This is a R2. We can add this R2. With constant speed, if both of them take same time to complete the circles, the ratio of their angular speeds will be. The ratio of their angular speeds will be. The ratio of their angular speeds will be. Okay. So now we'll see that problem. So 10th one. So 10th problem we see here. A car is going around a circle of radius r. So suppose let us see here, this is a radius and it is r1. So radius of r1. And another is going. So another car is going around a circle of radius r2 with constant speed. So now here another car is going with a radius, here it is circle of r2. This is r2 there. So both are moving with same speed. Both are moving with the same speed. And here same time. Time is also same there. Okay. Then they're asking their angular speeds. So the ratio of their angular speed. So omega 1 and here we can write here omega 2. And where the relation is there, no there. V is equals to r omega. V is equals to r omega is the relation. From this for the first car we can write here. For the first car V is equals to r1 omega 1 we can write there. So r1 means they have given here capital R, now we can write capital R only. So here we write capital R. So now r1 into omega 1. Okay. And here for the second car V is equals to r2 into omega 2 we can write there. R2 into omega 2. Okay. So now the velocities are same there. If their velocities are same means here r1. So this r1 omega 1 is equals to r2 omega 2. R2 omega 2. Okay. So now here what can we write there? This omega 1 by omega 2. So omega 1 by omega 2 is equals to, we can write here r2 by r1. R2 by r1. So r2 by r1. Omega is equals to r2 by r1. Angular, the ratio of their angular speeds will be, So omega 1 is equals to this one we can add here. So if the both of them are taking same time to complete the circle, the ratio of their angular speeds. So omega 1 by omega 2 is equals to, we'll get here r1 by r2, r2 by r1 will get then, r2 by r1. Okay. So next problem we'll see then. Now exercise problems. Yes, now here this see there, 11th one will see there, exercise problem. A vehicle is making revolution about its axis with uniform acceleration. Starting from rest, it reaches 100 revolution per second in 4 seconds. The angular acceleration is. So angular acceleration is asking there, a wheel is making revolution about its axis with uniform acceleration starting from rest. So if it is starting from rest means, so what can we take here? So 11th one will see there, 11th solution, 11th one see. So it is starting from rest means omega 1 is equals to 0, we should write there, and reaches the velocity. See here angular velocity is, it has reaches omega 2, that we can write here, it is 100 revolution per second, 100 revolution per second. And how much time it is? It has taken there 4 seconds. T is equals to 4 seconds. T is equals to 4 seconds we can write. T is equals to 4 seconds. Now they are asking their angular acceleration. So alpha, angular acceleration is what their alpha, no? What is alpha here? Okay. So we know the formula, first equation of motion, omega 2 is equals to omega 1 plus alpha t we can write, no? Omega t plus alpha t. This is our first numerical, first formula. Now substitute here, omega 2 is there, omega 1 is there, and here alpha value is there, and alpha value we should find out, theta value it is given there. T value it is given there. Okay, now substitute here in this formula. So omega 2 how much it is given there? 100 now. 100 is equals to omega 1 is 0 plus alpha we need to find out. T value it is given there 4. T value it is given there 4. Now from this, so 100 is equals to, it is 4 into alpha it will become there. So from this alpha is equals to how much it will become there? 100 by 4. So 100 by 4 means how much will get there? It is a 25 no. So 25 revolution per second square, revolution per second square. So therefore alpha is equal to how much you get there? Alpha is equals to, so 25 revolution per second square, revolution per second square. That is the answer. Now the correct answer is what there? This second one is the correct answer. Okay. It's clear? So second one is also, it is asking from the above, from that data only. In the above problem, the angle rotated during this 4 seconds. So in this problem only we should find out angle rotated, means angular position we should find out there, angular position. So for that what we have to use there, which formula we have to use there? Second equation of motion we have to use there. Second equation of angular kinematics. Okay. So we will see that one now. So theta value they are asking. So theta value is asking means angular acceleration in the first one. Then second one is angle rotated. Angle rotated is nothing but what there? There is a theta position, angular position we should find out there. So now 12th one we will see there. So all the data is same. All the data is same there. That is it is started from rest means omega 1 is 0 and omega 2 is what there here, that is 100 revolution per second, 100 revolution per second, and t is given here 4 second, t is equal to 4 second. Okay, and here theta is asking there, theta. So theta is equal to how much? So what is the formula for theta? Theta is equals to omega 1 into t plus half into alpha t square, half into alpha t square. This one is the formula here, and time is asking 4 seconds there. Okay. Now substitute here theta is equals to omega 1 how much there? 0, and it is a 4. Okay, plus here half into alpha value already we got now. How much we got there alpha value? In the previous problem we got there, that is alpha is equals to 25 revolution per second square we got now. So that we should substitute here. So that is a 25 here into t square value how much we got there? 4. So 4 whole square. 4 whole square means how much we get there? So from this theta is equals to, so 25 by 2 into here it is, so 4 whole square means it is a 16 will come there, 16. Okay, 16 means 2 1 ja, 2 8 ja will be there. So 25 and 8 will get there 200 no, so 200 revolutions. So therefore they are asking there in the radians. Okay, here it is revolutions we got there. So one revolution is equals to 2 pi radians, 2 pi radians. Now in place of revolutions you write that one, we will get here 200 into 2 pi, 200 into 2 pi will get here 400 pi, 400 pi radians, 400 pi radians. So therefore the theta, how much you get there here? Theta is equals to 400 pi radian, 400 pi radians. 400 pi radians. It's clear? So next 13th one. A wheel rotating with uniform acceleration, angular acceleration covers 50 revolutions in first 5 seconds after the start. So that means it is start. After the start means we have to take their omega 1 has to be taken 0 here. So that omega 1 it should be 0. So find the angular acceleration and the angular velocity at the end of 5 seconds. There. So that means It covers in first 5 seconds 50 revolutions. Then they are asking there, find the angular acceleration and the angular velocity at the end of 5 seconds there. Okay, at the end of 5 seconds means in the 5 seconds, the first 5 seconds, how much angular velocity will be there and angular acceleration will be there. That we should find out then. Okay, same in the first one we have done. No, we have done the first one, the same like that only. We will see this one. So 13th one, 13th solution. So we will rotating with, it is started from the rest. After start means omega 1 is equal to 0 here and covers 50 revolutions. 50 revolutions. 50 revolutions means in terms of radians it is 50 into 2 pi. 2 pi radians. That means here 100 radians will get there. It is 100 radians. 100 radians. Okay. So now they are asking a time t in the first 5 seconds. The first 5 seconds. It will be take 50 100 radians in first 5 seconds there. Okay. So now what is the angular velocity? They are asking first one. Angular velocity omega 2 is what there? Omega 2 is equal to how much? So omega 2 formula we know that now. So omega 2 is equals to omega 1 plus alpha into t. Alpha into t. So how to find out then? First we should find out the angular acceleration by using this second equation of motion. Theta is equals to omega 1 into t plus half into alpha t square. First we should find out this one there in the first t seconds, so that we can use that formula, so that we will get that value there. Okay. And here in the first 5 seconds, how many revolutions? 100 pi radians. 100 pi radians, no, it is then 100 pi, that is equals to, it will be 0 here. If you write here this one 0, 0 into 5, that is 0 plus half into, so this will be the 100 pi. Alpha only we should find out now here. So alpha we should find out means we should write as it is here. So alpha t square value how much it is? 5. 5 whole square means 25, it will be there then 25. So this will be 0 means 2 pi, 200 here. So how much you get there? Alpha is equals to, from that, so 200 pi, 2 you multiply here, if the 2 is multiply here, 200 pi it will become divided by 25. So 200 pi divided by 25. 200 pi divided by 25 means how much you get there? 8 pi will get there. So therefore alpha value, alpha acceleration is 8 pi, we got there 8 pi radian per second square, 8 pi radian per second square. This is a angular acceleration. Second one we got there. And their angular velocity. Angular velocity means substitute here now. So here we should substitute there. Omega 2 is equals to, this is 0 plus, so this will be the 8 pi into 5 there. 8 pi into 5. So therefore angular velocity how much we get there? Omega 2 is equals to, it is a 40 pi radian per second. 40 pi radian per second will get there. So this is a angular velocity after 5 seconds and angular acceleration after 5 seconds. So where is the answer? It is there 8 pi and 40 pi. So angular acceleration is this one. Angular acceleration and angular velocity is the option 2. Option 2 is right one. So remaining problems we will see in the next class. Thank you children. Have a nice day.